Hello everyone. In this lecture we will be converting another NFA to a DFA. So given below is the NFA for a language L, which is a set of all strings over 01 that ends with 01. So we have to construct its equivalent DFA. So here we see the transition diagram for this NFA, and here we have the transition table. So we see that we have three states A, B and C, and A on getting input 0, it stays in A and also it goes to B, and on getting input 1 it stays in A itself, and B on getting input 1 it goes to C, and that's it. So this is the equivalent transition table for that. So how do we know that this is an NFA? We see that A on getting input 0, that is a particular input, it goes to two different states. So this is a property of an NFA which cannot be there in DFA. And also we see that B on getting input 0 it goes nowhere, it goes to 5. And also C on getting input both 0 and 1 it goes to 5. That means it does not go anywhere. So this is the property of NFA. So we have to convert the equivalent DFA. So let's see how we can do this. So first of all we will be using the subset construction method, and for that we will be making the transition table for the DFA. So let me draw a table here. In this table we will be making the transition for the DFA. So what will be the elements I have? I'll have 0 and 1, which will be my inputs, and I'll look at this table. What is the starting state? A. I'll start with the starting state A. I'll give this arrow to indicate it is a starting state. And A on getting input 0, where does it go? It goes to states A and B. But in DFA, we cannot send it to two states. So we will convert this AB to a single state, which I will call AB. And A on getting input 1, where does it go? It goes to A itself. So that is okay. We can do the same thing here. Now, how do we define the next state in this DFA? So we have to look at these states, and we see that we should search what are the states reachable from this state, and the states reachable from this state are A, B and A. A is already mentioned, so the next one is AB. So we will make the transition for AB. So AB on getting input 0, where does it go? And on getting input 1, where does it go? So in order to check for AB, we have to check both A and B in this table, and we have to perform the union operations of A and B. So AB on getting input 0, where does it go? Perform the union operation of both A and B in this table. So union operation of A and B will be A, B and 5. So it will be just AB. AB. And on getting input 1, we have to perform union operation of this one. So in union operation of A and C will be AC. AC. Okay, now we are done with that. And what will be the third state in this table? Here we see that the states reachable from here are AB and AC. So AB is already done. So the next one is AC. We have to make a new state, AC, and let's see what happens to AC. So for checking for AC, we have to perform the union operation of A and C in this table. So on getting input 0, it will be union of this AB and this 5. So it will be AB5. It will be AB. AB. And then for input 1, union operation of A and 5. So union operation of A and 5 will be just A. Okay, so now we have finished the transition table, but we did not mention what is the final state in this table. Initial state is A, but what is the final state? In order to check what is the final state, we look at this table and we see that here C was the final state. So since C was the final state here, in this table, whichever states that contains C will be the final state. So we see that here AC contains C. So AC will be the final state in this table. Alright, so now we have finished the transition table for this DFA. Now we will try to design the transition diagram for the DFA. Now we start with the starting state, that is state A. Start with A. A is my starting state or initial state, and A on getting input 0, where does it go? It goes to AB. It goes to AB on getting input 0, and A on getting input 1, where does it go? It goes to A itself. It goes to A itself on getting input 1. Okay, now we have completed A. Now let's come to AB. AB on getting input 0, where does it go? It goes to AB itself. On getting input 0, AB goes to AB itself. And AB on getting input 1, where does it go? It goes to AC. So we have another state here, AC. And also let's remember that AC is the final state. So we'll put 2 circles around this AC. So AB on getting what input does it go to AC? On getting input 1. So on getting input 1, it goes to AC. Now let's come to AC. AC on getting input 0, it goes to AB. It goes to AB on getting input 0. Okay, and AC on getting input 1, it goes to A. So AC will go to A on getting input 1. Okay, so now we have drawn the transition diagram for this DFA, and we have successfully converted this NFA to its equivalent DFA. So what was the task of this NFA? It accepts a set of all strings over 0, 1 that ends with 0, 1, right? When it ends with 0, 1, it's accepted. Now let's see if this DFA also does the same thing. Let's check for some strings. Let's take some few examples. Let us check for the string 1, 1, 0, 1. So 1, 1, 0, and then 1. It comes to final state. It is accepted. Let's check for another string. Let's say 1, 1, 1, 0. So 1, 1, 1, 0. It is in AB. So it is not accepted. So when it ends with 0, 1, it is accepted. When it ends with something other than 0, 1, it is not accepted. So this is how you convert the NFA to its equivalent DFA. I hope it was clear to you. Thank you for watching and see you in the next one.